Hi, everybody. Going to play around with something a little bit different today, mainly because somebody sent me a link to a paper about 10 minutes ago, and it's pretty relevant to the stuff that I'm doing, so I figured I would actually go through and, like, maybe try and hack up the paper and see if some of it can be salvaged or changed or mangled to fit what I'm doing or subsume other work that I have going on. Curious to see where that goes. The main thing that I did since the last time I broadcast, which I think was like, what, a day or two ago, was I wrote a bunch of stuff for doing delimited continuations in Reflection Without Remorse, and then I realized that that had also been implemented by Atsi Venderplug. So it was already there in the Reflection Without Remorse source code repo. Maybe I should read source material a little better. So what I have right now is this little monad, which follows pretty closely to the CC Delcont code, which I believe is some pretty old code from Kent Dybvig and SPJ and Mir Sabri and Oleg and a bunch of folks have touched this, but mostly a decade ago. So in there, what they have is this monad CC with delimited continuations, and it has the ability to craft these things called prompts, and then you're able to capture the portion of the continuation up to the prompt. And they rely on some magic region discipline stuff and a little bit of unsafe coerce to make it go. Fortunately, I think I already have all the stuff that I need for unsafe coerce to do this in the form of the prompts that I have inside of Guanxi. All of the key machinery is basically the machinery that I need for a safe prompt. So if I look at the prompt code, right now what they have is, like, prompts are just numbers. And then they rely on the fact that they are going to manufacture them for you, and please trust us, to recover type equality information from the prompts. But if you had the monad key stuff, you would have the ability to do this directly. So since I already have keys work as prompts. Have I fixed the lighting? Yes, somewhat. I'm trying a different arrangement of things around here, and I figured out some tricks to get better capture on the green screen. I did that, I think, last session or the session before. Hopefully this will be the new normal. It also helps the hour, so I don't have the daylight pouring through the door. So this system of prompts is usable, but I kind of like the idea that if I have keys, I can use them to actually get me this once and for all, using the same machine I'm using everywhere else inside of Guanxi. So the machinery for the monad for delimited continuations is this. You have the ability to create new prompts. You can push prompts into your monad, which delimits the computation up from that prompt. And then, given a prompt, you can ask for the portion of the computation since A to your current state B. Or since B to your current state A. Or it's the other way around, but the idea is right. So you can kind of peel off a portion of the stack. And here you can say, all right, I want to take this subcontinuation and run it with an A and get me back a B. And then off of that, you can build the traditional shift and reset and some other control operators that are a little less traditional. Couple observations here. These things have kind of a funny style. They put the M on this argument, unlike call CC, which usually doesn't. So when I went and implemented them myself, I kind of built it both ways just to see if I liked it. With it in there, the original Dybvig and SPJ, etc. paper does make an observation that it can get a little bit more sharing and stuff like that. You can have better computational efficiency and avoid some leaks. So having both of them is useful, I think. But yeah, so this is the API that was implemented originally. Hi, Emily Pie. How you doing? This is my transcoding of it to slightly more modern Haskell. My prompts are now type families, and my form of subcontinuations are also type families. And I'm asking to use the data.type equality and type coercion stuff straight out of base now, rather than like some magic prompt. And then that I want my subcontinuations to form a category so I can compose them. And then with that, I can build these combinators once and for all. So anytime I have these delimited continuations, I can recover the power of call CC. I can build the div-vig and sabri and spj, etc. style version of them where I've got the extra m here, or I can build the more traditional form, and I have a version of call CC that also does the same thing. And then I built a little instance of this thing for lifting over monad reader because it was obvious, but I didn't really test it or do anything with it. So once I got this, I've got the class. Now I want to use it, and the implementation that I wrote was in terms of the reflection code, and it has been gradually unboxed to the point where it is somewhat terrifying, I admit. Let's see if I can get the right resolution here. There we go. All right. So my prompts are just keys for whatever the key state is for the underlying monad. So I'm going to work with the CCM as the monad without the region parameter R. Sorry, Taneb. Clearly the solution is to not go to bed. Let me pop up my chat window so I can have it on the... I can have more screen real estate off screen. Of course, that costs me the ability to see messages that I've already said. So when I was building, so I built like free and freer using the reflection without remorse style. Here I did the same thing using for this CC monad. It's kind of a mess. What we have is this. For a single delimited continuation, I have some prompt that starts the delimit, or the delimited section, and then I have a series of Kleisli arrows in my CC monad to the right of it. Okay. Then a subcontinuation from A to B is going to be a bunch of actions, then a bunch of these segments. So I start with Kleisli arrows, or I guess I end with Kleisli arrows. Then I have delimited sections. Then I have Kleisli arrows again. This is actually pretty close to Etsy's code. I think the main difference is that I've unboxed everything to avoid creating random intermediate data types wherever humanly possible. And I built a little toy example using it to actually test to see that it actually did something, and it did. So I've got the ability to run these chains of Kleisli actions. These, remember, so cat is the type align sequence stuff that I have, where you can work with. It's the stuff from the Reflection Without Remorse paper. For those who don't know what the hell Reflection Without Remorse is, which I've been rambling on about. Without remorse. let me pull up the paper. It's an Oleg paper. Well, technically it's a Etsy paper. I'll paste it in chat. So that paper is the source of all the delimited continuation stuff that I'm using and a bunch of other things. I don't know if they actually talked about the delimited continuations in the paper. They probably did. I am a terrible paper reader. So once I've got my subcontinuations and can glue those together, we can build the monad. I wound up with this weird result where the minimal set of constraints I could put on M in order to implement this thing was applicative. So you can build the monad and work with it, but in order to build lift pure here, I have to use pure in the underlying monad. So unlike the usual continuation passing style monad, I don't get to get away with no constraints on M. But I wind up with this applicative. But then running it later, I need to know that M is a monad anyways. So when I get down to actually like quotienting out all of this structure so I can just see how to run it, you give me some action that you want to run. You give me something to do if I fail to find the prompt in the stack, which is like kind of the thing I was really unhappy with this paper in the sense that it like lets you screw up the use of prompts. I guess if you stick with shift and reset and whatnot, that it's okay. But it's kind of annoying that it doesn't show up in the type. If I did make it show up in the type, I'd have to use like an indexed monad though. So I understand why it's not there. This is one of those few places where like the effect system folks have a right story, I think. You could like track it as like a index in your like an indexed effect story. But basically what this is doing is we run the continuation. We either have a top level computation that we want to just run and we bind and go into the subcontinuation, or if we actually need to know where find this particular prompt, we go through and I split out finding that appropriate prompt, rips apart the entire like delimited continuation and turns it into a delimited continuation, a run of things up to that prompt, and then everything after it. Ugh. Kind of horrifying. I'm not expecting people to follow along as I ramble through. The main takeaway is that you get this run prompt computation that says we can either run CC using monad fail for what happens when it's missing, or you could call run CC directly with an error for when it's missing, which would mirror the behavior of CC delcont. And run prompt gives me just the ability to not care about like where I got my supply of names or supply of keys and stuff from, just by running CC and then running it on top of ST. So this is the like workhorse method. All of the rest of the stuff is implementation details in order to get continuation passing style. All right. So I've got a little toy example, which I think is also in the delcont code. Here what I'm doing is saying an iterator for some monad is just, I'll give you an A and I'll give you a way to read the next level. It's almost a list T done right, but I don't have the first level of monadic effects. And then given one of these things, I can ask for the view of what's the head of it and what's the monadic effect for the tail. And you get this like Kant-like construction for how to construct an iterator. And we can do things like build the iterator that works for M from 1 to 5, because if you look at the type signature of 4M, after it's been applied to an argument, this thing fits the right pattern, and then loop over this thing, and then mangle my state, which I then report in the done case. And this will do something like spew out a bunch of repetitions and stuff. It's cute. So why am I playing around with this? Mainly because I currently have like 2 or 3 different things that we're all tossing around continuations in the last session, and I'm somewhat interested in getting like dynamic wind and the like, and seeing whether or not I can make it so that as I go in or out of different sections of code, I replay or destroy certain effects on my reference types and on the heap. And basically, what I'm looking for is a way to track where I am in my like tree of computations, because I've got like the parallelism story at the top, this concurrency story inside of it. Within a universe, I have all of these different threads that want to work, that are working on a consistent set of references. But then I have this non-determinism layer, and it's getting fairly messy. So I'm looking to see if I can come up with some kind of unifying framework to hold it all together. And right now, this is one of the candidates. So that's what the prompt stuff is. Trying to think of other changes. What's happened in the last couple of days? Today is the 5th. All right. What other changes have happened here? It should now just work to do new test. So I found a package from somebody that does a doc test discovery, which I'm actually pretty happy with, which means that I can actually use a Cabal 2.2 style build and still have doc tests, which was pleasant, which means I can now get rid of my custom builds, at least for new code. So I'll probably do the same thing to Coda today or tomorrow or something like that, whenever I get some downtime. So here the test suite now just has this tiny little cat doc test main. And do I have bat installed? That doesn't really change anything. But if I do, and then I've got my spec tests are currently also run through a similar harness. So I was using HSpec Discover already, and now this uses DocTest Discover to do the same thing for finding all of the triple arrows to the right and then validating that they actually work. And then the config is just looking source for it. But previously what I had was I couldn't have a backpacked style configuration where I wanted to use the new build and multiple libraries and stuff like that, and have a custom build type, which I needed in order to support the setup hack that I use to robustly find doc tests. So having the GHC plugin based version of it that just finds them by file and runs them all, I think is a pretty viable solution, and it seems to be working stably right now. I will perhaps revisit this when I try and run stack or something for this rather than just using Cabal new build for everything. I don't know how well that works in that scenario, but it does make my tests very minimal looking. What else is there, like, administrivia wise before I go on and start trying to read a paper? So somebody sent me this link. Unfortunately, when I opened it up in IRC Cloud, I did it on my phone, and then went, oh, and I clicked on the link and I found the name of what the thing was. But somehow because that used up the notification, I don't actually know who sent me the link. So if you're watching, tell me. If not, tell me. So this explicit sharing thing is the next topic, I think, of discussion for me. Let's see where I put it. So there is a library here for explicit sharing. Let me pull this over to this side, I guess. And it is by Sebastian Fischer. It's got a bunch of input from Oleg and some other folks in the original paper. Uses this funny little shareable constraint. And there's a bunch of things in here that, like, I understand why they did them, but they're going to drive me out of using this particular package and probably into implementing it myself. Mainly, like, seeing, like, C's of these kind of ad hoc looking constraints with no no fund-ups relating these things means that this is going to infer very, very badly. And then I don't really like seeing things like this floating around when I've got other constraints like this, you know, like, because now this means that everything that, like, sits in there, I can't have a type with a parameter that is shareable, like a proxy or something like that. That feels wrong. Like, this is, again, just sort of an initial reactions to the library and, like, the approach. So I'm interested in trying to see what we can steal from the approach. But the idea was, how do you get non-determinism and laziness to play nice together? And I think that that's a thing that is near and dear to my heart. So I very much like the mission statement of the thing. But yeah, this is even worse. Now we've got 3 parameters floating around with no constraints between them, and it's just going to go into this inference hell. Especially when you've got things like this lying around. But they gave a paper that has a bunch of nice laws. Let's see if I can pull this up. Sorry, I'm flailing between windows here. Where was the paper? It's on their site. Subfish, GitHub, explicit sharing, tutorial, paper. The current interface differs from the original version. Non-det is now shareable. That's fine. Alternative implementations. Monadic actions is first order data instead of state passing functions. All right. So where's the paper? This is dump the link here in chat. So this is the thing I want to play with for the next little bit here. We'll see how far we get, and if we get stuck or want to do something different, we can do something different. But the idea I had for right now was to just kind of slog through here, implement it badly, see what life lessons we learn, and go from there. So they have an example being like, let's start with permutations, and then build a sort by naively computing a permutation of the input and then checking to see if it's sorted. And then making that slowly, like, more and more efficient by giving up sharing, and then, or like getting back to the non-strictness by giving up sharing and then bouncing around between this thing. So this list MA is almost a the list T done right construction. Kind of like my iterator is almost But here they have M effects on the heads. So I have not actually read this paper. So this is the problem of trying to do this live. Is now I'm trying to read the source material at the same time as implement it. My original plan was to just kind of go through the library and, well, kind of mangle it side by side. So let me pull up the explicit. Sharing repo in another window, so I got the code. Take the monadic list. So the other thing is this monadic list that they have. This is the one that they're using there. This is like M of, all these computations take an M of list A, which is really awkward. Like, this feels like list, this should be list T MA, and then these M's would be, then this would just be list TMA. I get MAs to list TMA. I don't really want an MA there. But I'll take it. Yeah. So let's first do this. Let's build list T done right. I've got logic. I'll probably use it as a proxy for this. But, yeah, we'll build it. List T is an M of either A or a list TMA, right? You know what I'll do? There. Wait, do I have this as the naive free already here? M of A. Oh, I already have it. This is the logic.naive. I already have this implementation. Sweet. I don't have to build it. The code-free identity is going to miss all the M layers along the way, though. So I already have logic.naive. I don't need list M. I can just repurpose logic naive and everything that they're doing with this. Fits. Is empty first rest. Okay. So we can live with this thing. So I'm gonna first substitution, I think, in my half scan of a paper is that I'm going to mentally substitute logic T or logic.naive whenever I see M of list inside their code. Because we've got an isomorphic representation. It already has all the same kind of plumbing. Sweet. We've made progress. Kind of collapsing their vocabulary and our vocabulary together. What else we got? So I think the main key that they're trying to implement is this sharing computation where they take an M and give you this M of MOA, which is what share is supposed to do. The thing that's like kind of hellish here is that the M and the A are both sitting there as parameters to that, which bugs the heck out of me. I could fix that by doing that in a little backpack container where M is like a parameter, like we parameterize the whole container, like the whole library on yeah, let's try that. So we've got the base library here. Let's just play with this as like library sharing. First of all, we need base, right? Import base, which is this common block. Wall and Wextra is already in there. Default language is already in there. I don't need that already. So that was just me spotting that I had screwed up. I'd factored those out, but then failed to use it. I'll put these off to the side. Signatures. We'll parameterize in some monad that we're going to work with. So last time when I did one of these kind of modules, when I was playing around with it on the Mac, I showed this kind of pattern. I want MSA, type MS. I want a data type MSA, such that I have an instance of functor for MS and a there. Now we've factored out the choice of M. That's all we're going to know about our monad for now. That would be the share that I'm playing with. Now I'm basically only been going for about 5-10 minutes. Okay, maybe longer than that. Maybe 30 minutes. Yeah, Uptime here has speech synthesis capabilities. All right. Pulling up that shareable code. Yeah, so sharings, I guess this is shareable. A. Come back here. So like by default, these things are going to be boring, right? Instance, shareable, bool, where share, like they have these funny share args thing, right? Rather than share. Let me go pull that thing up. Merge this into that window so I can flip between the two. That would be good. All right, so sharearg says for any shareable, if I have a computation that works for any shareable B, takes an M of B to an N of M of B, I can turn A into N of A. Let's build that thing. Shareargs monad M. For all monads n, because I have for all b shareable b, because I don't have the m constraint anymore because we've curried it out. MB to n of MB to A to n of A. That looks like the analog. Now that we've pulled out the monad, I'm much more comfortable with this thing. So it's a shareable bool and stuff like that. So do they use this share args thing, or I'm gonna have to actually read the freaking paper, aren't I? Share args. This is where the paper started diverging from the explicit sharing. So map non-det is the thing. That's right, they had a different name. So when they do map non-det, we believe it can be automated using generic programming. Well, that's been the axe we've been grinding on this stream so far. Thanks. I'll put the E in. Given anything non-deterministic, we can walk over. Why do I need eval? Takes a non-det MA to A to MA. Okay, so can we? Yeah, the fact that they want to do this with generic programming is a good sign. I'm just trying to figure out what they need to actually, what other calls to map non-det they actually make advantage or take advantage of here. Separation generated. Oh yeah, that's right. There was a specific version for lists that they'd given. List of memos. Give me a memo of list of memos. Define an eval or something like that here. Let's build, yeah. Share, walk through this thing, and just do return. This is going to be the kind of standard pattern for like built-in types. Shareable A, shareable B. I'll see how long I can stream. Amy's off doing, she's at a client that's doing work and stuff, so I have some downtime here. Like, I could do this with generics. We're going to build G shareable before we even know what the core abstraction is. Let's go eagerly evaluating my abstractions, shall we? Share args tells me, or G share args, monad n, for all B, shareable B, M of, this is an N of M of B, FA to N FA. Instance. Let's just work through how to do this. By default, G shareable K1IC. both cases. Thank you very much. G share args for K1IC is boring. You've given me an F and a K1M, and I'm going to fmap K1 over the results of calling G share args FM. No, wait, I already have the fmap. But it's not G share args, it's share args. So we'll do M. Just gets us past all the metadata. We just need to deal with sums, and M is declared up in monad. Do I have this in? So monad's an abstract signature that's just supplying this, whatever monad we're working with. Did I put up signature monad, please? So we've got that. Let's walk through products and G share args F. I'm going to get this into oh, I did build that already. Control P, maybe I can actually get this thing to build. Oh, because I've got a harder GHCID sharing. Can I just do that? Or do I have to? No, I have to. So the only problem with putting this library here is this now screwed up my GHCID config. So no longer, I can't just have it build the Guanxi library. It has to maybe. What am I doing here? VI sharing. Come on. No Emmys, no Emmys. Build the library. Multiple components. Yeah, this is what I was afraid of. And then let me go hack up my. Can I just do that? For right now, I'll do horrible things. Pre-processing library exited with call new REPL sharing. What goes wrong here? Oh, because I guess I can't do the new REPL for a module signature. Let's move that into common. We'll make a library that uses that thing, maybe. We depend on sharing and common. mix-ins. I need to supply a monad for this thing. God damn it. Means I need another library. This is the problem with Backpack. So we've created one solution, but it's causing us a whole bunch of pain. All of this to get rid of one parameter to a freaking monad. Oh wait, I've got FDS. I will just choose. Yeah, this is the right shape. I'll just bolt that horrible thing in there. Mix-ins, we're going to do sharing. What's the syntax for this stupid thing again? And if I remember right, this paren has to actually be on the end of that. Something, blah is something, requires. Sharing. Sharing as fd.sharing requires monad as fd.monad. So now this will, and then I need to re-exported modules fd.sharing. So in theory, this will build a library that's called Guanxi that only contains FD sharing. Terrible. And then I've got a FD common library, or a Guanxi common library. Cabal new build FD sharing. So we're building the common library, building our sharing library raw, then we're building it locked into FD monad, and then we're building FD sharing. That's going to complain because I don't have the sharing stuff, right? But in theory, sharing. Let's just get this down to proving that this compiles. Just hack that up so that hopefully I'll have some kind of GHCID config so that we can get that magic snappy feedback that's been so good over the last few streams. Wait. GHCID minus C, cabal, new REPL, Guanxi. Come on. FD sharing? Because I currently have it angled off to the side. All right. This is a crime against God and man. All right. I don't want to build an enormous library here. I'm going to re-export everything from common, which is going to suck. Because I have to repeat myself like 30 times. Let's try this. I have to put commas between them. Re-exported modules is a different signature because you can put re-exporting things as something else. I'll be clear about which ones were re-exported for sharing and common. All right. Maybe that will work. Now I will mangle my vim config again to go call new REPL guanxi. Now, please build my library and do the right thing. So build fd.sharing, but doesn't have any content, but sharing. Or you're not taking it. No files loaded. Well, let's export a thing. There, I got a module. Just to test it. The top level, I will have an exposed module, guanxi, which eventually will turn into some big re-export. That should avoid the empty library problem. Which is just really GHC being lame. And I think that's good. To mangle the guanxi file to actually read that from source. Source. And, you know, these are getting complicated. There we go. Common source, all this stuff. There. Now we've got the. Do I need to mingle any of these? No, those seem to be looking in reasonable locations. Okay, so new build is doing a build. Probably just mangle my new vim configuration to cabal new REPL whatever directory I'm in by default, and that should get everything. So cabal new REPL should now cabal new she. I'm in this thing. I'm in my monolithic import thing. I have access to all the others. Yeah. All right. And then GHCID minus C. Cabal new REPL. Guanxi. All good. One module. This bodes not well for dynamically reconstructing it when I mangle things in the other files. VI source sharing. Start building. It's not watching the right files though. It's only watching that. That one module, cabal, GHCID, Zura. -- reload that thing. Config and vim. What if I just moved this into a .ghcid file? -- reload equals source sharing HS maybe? That sound plausible? Still working my way around the new tooling. Do I need to put spaces around that? No, this is annoying because GHCID isn't going to see me changing the backpack code. So I don't know what the right solution is here. Cabal new REPL Guanxi is not the right thing. How do I get GHCID and backpack to play nice together just so I can have backpack for this one little toy, which I'm totally mingling my entire repo for? Huh. So yes, stupid tooling problems happen to everybody. one of the reasons why. Let's start the thing here so we can see some computational content. Let's put that in there anyways. Restart might work. Let me turn on enough extensions that this thing actually passes. Rank n types. What other things do I need? I'm going to need type operators. It's totally, because it's crashing completely, I'm losing the, wait, I can, it's shareable and undecidable instances or something like that. Parse error. K1C had a parse error. Why? Because I totally forgot to put a paren in there. Share args. This is a G share args. Yeah, this is, I'm gonna have to do a restart, you're right. It's gonna be big and expensive, but alright, I think your restart story, Adam is the right thing for now. It's awful. It's nowhere good as the tooling that I like, but it'll work. Share args. We've got a bunch of base cases. Chars and lists and ints and stuff. And right now it's gonna restart every time this file changes, which is a hack, but it'll get me going. And then I'll decide whether or not it's worth having this thing in full backpack glory as we go. Oh, I've got 2 shareable bools. And I want default share args. As long as M is, or no, what is it? Generic A and G shareable. Rep F, rep A, and monad N. The sign showing me the error. So I'm using the GHCID NeoVim plugin. That's actually what forced me to move to NeoVim, which has caused me all sorts of muscle memory pains, but it's been worth it, I think. Do G share args FM. That's like 2M. And then it's like from. Shareable int. Share args. Share args is not a visible member of shareable. Share arg. The usual experience is much better. If you look at my last session, it's been quite pleasant. This is a bit of a mess. I guess everybody else here is share args. Share args you win as the name. Even though it's wrong. Whatever. The fact that this is crashing every time. What's the GHCID? There's a let me just look at we're just picking a random file. It's a Haskell file. It runs that's what I wanted. All this crap. Cabal new REPL. How do you pass GHC arguments to Cabal new REPL? Do you know? That's wrong. First of all, Cabal new REPL. Flags, deterministic, no. With prog ops, with GHC ops. GHC option. What do you do if I do that? -- GHC options equals. All right. This last one is not a GHC option. I kind of want to just pass all this crap to GHC. Is it -- REPL options? not match the corresponding default signature. What did I screw up? Monad N, shareable B, MSB N, all this crap. A to N A. Flexible contexts. Well, first of all, let me fix this thing up so it doesn't crash. We'll do this old school. Sharing A with rep FA, blah, blah, blah. Might add these backwards. Can never remember. Given how much I use them, it's embarrassing that I can't remember. Okay. So that REPL options, can I pass multiple? No, I have to pass each one of them separately. All right, that seems stable. And if I mangle this with garbage, it still crashes. I wanted the, I was hoping for GHCID to not die. Thanks, Cassie. After all of that, it's still not doing everything I want. F no break on exception, F break up. F error spans, REPL options. I don't need the -J. I've never actually tried mangling this directly like this. I just want this to give me the errors that it's given me all the other times. See, this GHCID exited thing is killing me. It found the error. And I have to rerun it. Oh, yeah. That'd be a good question. Cabal REPL options. Control freaking F options. How do I pass multiple options? Call new REPL, ignore project, blah, blah, blah. Never actually had to use this thing. I don't know, actually. I would think that they wouldn't, but I guess we could try. Let's flip this around. No break on error is not a module name. GHID. I have to put a dash F in front of it. That's a typo. Garbage. GHI still crashes. I don't know. I'm crashing out every time I try and do it, so it doesn't seem to matter that much. If somebody comes up with a solution, I'll happily take it. How's that? I'm going to move on with my life because this is not what I wanted to spend my day doing. This may just drive me to merge it back in and accept the fact that I'll have shitty inference. I don't want it, though. I could just like do the poor man's version of this thing and then move this thing back into the main library and then just import fd.monad and program against that for now. And then everything would be good because M would be known. Now you compile faster. Lame. Kill all that. We'll just export sharing. As a starting point. And this just becomes library, and then we go back to a default build. Does it build? I just want a decent user experience again. We can try. Wait, I need the... Oh, is it? DHCID, do it. -- REPL options. All new REPL. Inside my quotes. Screw it, I'll do it myself. -C. Cabal new REPL. Can we get through parsing command line arguments recursively in 2018? Unrecognized flags, F no code. Yeah, see, this wants to pass them separately, I think. Because it's not taking that as separate arguments. Try that. If I put it in the .ghcid file, I'm guessing it's not going to support the quote properly. And we're going to get crap. Yep. So ghcid, when it parses the .ghcid file, this thing isn't getting string quoted by the shell, therefore, yeah. I think I'll just file that as an issue. Because there's no way for me to pass complicated command lines in a .ghcid file. But copy that. Maybe I can cram all this into this. So that's not taking it. Of course, I can't see what went wrong. Alright, it's not as fast as it could be, but it'll get us going. Whatever. And it doesn't freaking crash anymore. myself that that's lame, and then come back to it later. So we've got the share args thing that seems to be going. This thing bothers the heck out of me. All of those do. Shareable functions. They don't need anything to share underneath them, they just share. And they build that lazy monad, which they don't expose to anybody, which is really kind of annoying. Sharing lazy n, but we'll never tell you what lazy n is. Contents. So non-det gives a failure and a huh. So non-det is their like join semi-lattice. Oh no. It's got this self-abide law or something like that. It's a very strange law. It's idempotent and self-abides. If you're curious what I mean by abide. Actually, I can just open it here. I wrote an article on Command.com about 10 years ago, which talks about this abide relation. This A, B, C, D thing. Given a pair of binary operations, which have an interesting property that if they have units, then they coincide. There's this Ekman-Hilton clock, yeah. If two abiding operations have identities, then they're equal to each other and commutative, and the identities coincide. So we have an operation that abides itself, and it has a unit. Well, we don't know that it's a unit. We haven't determined that failure is a unit for this. It's a unit for all their examples. Maps to rationals being viewed as add them up and then divide by 2. Yeah, it's the same operator, question mark and question mark, rather than the bar operator that usually happens. Like, notationally, this is, you know what, I can probably have a little pen here. Hopefully this won't destroy everything. If I were to tell my screen to mirror, I always hate doing this because it's always like, okay, let's hope it works. No. Multiple displays, duplicate, keep changes. Screen sketch. All right, so like there's this funny little like, I think it's like, give me a pen color that's not white. A Like, if you read the laws this way, you can turn them into A over C bar B over D. And that's why the funny choice of notation with the, like, circle bar and circle plus, or, circle, so you can convert this, if we wrote it in this form, over into that. I think I'll just go back to display settings. Now where did I lose everything to? You get back up there. Code, you get back up there. All right. Where did I put my Twitch chat? All right, that was really disruptive to draw one little sketch. Let's not do that again until I can figure out a cleaner way to avoid destroying my whole desktop. So we've got this funny little shareable thing. Yeah, their non-determinism class. Let's see if we can actually get something written that's actually worth writing. We've got products, we've got these things, we need to do sums. And that's a plus. Let's go even further in and do shareable 1f. But then shareargs1 is also going to take a function from A to, I need to be able to do this for the oh god, that's annoying because I have to pass the you tell me how to do this for an A. And I will tell you how to do it for f of A. Might as well be consistent. Or not. And then I will just have this thing reference itself so I can save some instances. Default is going to require generic 1f and shareable 1 rep 1f. a monad. What's that? All of this so I can get G shareable for colon dot colon. No idea if I'm actually even going to use this thing. But anything worth doing is worth doing generically, even before we've done it the concrete way once. GF. G. And then this thing is a from one. And we'll wind up with shareable ones for all of this stuff, just like we wrote all the G shareable stuff. And shareable K1C, this is okay. G is irrelevant here. G gets passed through. G share args 1, G share args 1, we pass the G. G share, this is not G share args, these are. These don't have a G shareable 1. These aren't G's, they're just share args 1s. Really tedious for people to try and follow this logic at home. I apologize. Shargs 1, Shargs 1. G, G, G. That's flat. Good. All right. And we just need to figure out how to do the shareable 1 for dot. By the way, is this thing building? G share is one. Yeah, it is building because we got the colon. We got the thing telling me I screwed up the names. All right. Comp 1x. Put that thing back on. Share args 1 of. How do we do this? We recurse into its arguments by using share args 1 G F X. Yeah, it's happy with me. And up here, I need a G shareable instance for shareable 1 there, but only need G shareable for G to get G shareable F G, and this is G share args. Pull this G out of there, and this is now cursively calling G share args instead of. That looks like it's plausible and compiled. All right, so we've got all the generic stuff that was hypothesized in that article, at least for that one particular class. As long as I've factored out the monad, so I don't need to deal with it. Because it being there makes me sad. I might put it back in anyways, we'll see. For now, I'm going to try and stick to this MS pattern. All right. If not only because it helps inference there, but it also means that MSA is definitely not going to unify with char SA and all that kind of stuff. Char and all those other things. What is the status of propagators? This is actually all about propagators. If we look at source common signal, or common, where are we? Ref signal. This is a propagator mechanism. So the mechanism that I'm using to make Guanxi go is all based on propagators. What I have are signals, which are the cells from the old propagator machinery, and propagators between them, such that when you modify the signal, all the outbound propagators get scheduled to fire. And the propagators themselves know their sources and targets, so later on I can do topological analysis and do all the things for propagators to make them fast. The main thing is I'm doing propagators not in this big, loose parallelism framework, but I'm doing propagators in a non-determinism setting. So we are living in logic T, and we're doing all of our work with functional references, where the functional references are like looking up stuff in a map. And that means that I can fork the whole world with Monad Plus, and all of the propagators and all that kind of stuff just kind of come along for the ride. So this actually helps a lot of the stories for propagators for things like dealing with SAT solving and all that other stuff. I still need some machinery for like communicating across universes. That's what all this conflict-directed clause learning stuff is about in the questions for Guanxi. So if you're just looking at this for the first time, above my head there should be a bunch of links. Admittedly, they're not in chat, so you have to type them in by hand, which is one of the reasons why most of them are tiny URL. Was that useful at all, Peter? But if we look at the common, what's a good example of it? Let me first of all rebuild my tags. Fast tags minus R. RAM tags. So I have like these finite domain variables which act as sets. So you create them with like a set of values they can take on, and then you're allowed to constrain them down further and further. And then when I'm finally done, they ground themselves out. So here's this like finite domain monad, which is actually the thing that I'm trying to build this other stuff on top of. And you can do things like this: build finite domain variables, set these things up, establish the propagators between them, and then go look at the values of them if you want to report them. But otherwise, it will not just establish our consistency, but full global consistency before like accepting an answer. And whenever along the way I learn another fact, before I've grounded everything out, I will tweak those sets. So one of the things I want to do soon is get like E-unification and some other theories into here. The sub goal for the day is trying to get the sharing thing to go though. So we've got shareable. We managed to build all the generics for it. We haven't built anything for this convertible thing. Is a damn mess. A to M of B as long as convertible M, A, B. No, I don't want anything to do with that at all. Sets for non-dot. Oh, non-det is the sharing thing, but that's a superclass of... Oh, we know that M is a monad plus. That's actually me learning more about the monad, but we already knew that because FD is a monad plus. Fine. This monad non-det eval is going to map non-deterministically this share args is kind of an awful name. So what I want is share to take, since we've locked everything down to FDS anyways, take a shareable A and take an FDS A to an FDS of FDS A. This is what share is going to be in the end, I guess, because we've locked M down to do it badly. So they build funcs, which are unevaluated as M's. And they have this notion of a thunk store. The ability to look up thunks. We need to get a thunk I. This is a named thunk. This is kind of awkward because this you have to trust that you got the right A. Fortunately, we've been building all this key stuff, so building the thunk store seems to fit well within our capabilities. Those are our references in FD. We already have FD. We can create thunks using the reference machinery I already have. So lazy for them is a state T of thunk store. But we already have the power of thunk store in our reference machinery. Memo takes a thunk store and takes an M of A to M of M of A. Let's do memo. How can memo work? So these are the things we want to build. We want to build share, and we want to build memo. Take an M of A, enter, this M is going to be FDS A. FDS A. Memo A is due. We're going to build a new ref. Set it to uneval A. Come back. What I'll do is I'll store either in it. I'll just store a left A. And then I'll return do read ref R or ref R read from it. So either an M of A or an A. This is my thunk. if it's a left A, yeah, this is all I'm going to do. I'm going to return computation that on a left A gives it back and then runs it and then stores it back in. That's annoying, because I want to do the store in one pass and I can't. So I might as well just do this the slow way. Read the reference. Okay, so return the computation that does this. Read reference. And then if it's left, we're going to do some things. The first thing we're going to do is run the computation. Now that I've got the M of A, I'm going to write the reference back in. Write ref R. Write A. And I'm going to return it. On the other hand, if it's an A, I'm just going to give you back A. So that's the computation I want to give you back. That's memo on top of anything that's Monad state SM has ref state. I need the I need references. I don't need anything else. I can take an M of A and give you back an M of A in general. Then share. Let me try and get this thing smashed so that, or no, eval. Took none.ma. Which is shareable in our vocabulary. It takes an A to an FDSA. An eval is share args. Eval fished to, what is this? This is take A, bind it to eval, find that to return.return. Let's figure out what the hell that is. Does that compile? Garbage in here? Check, make sure it compile. Nope. First of all, build. Memo. Line 85. What did I screw up? Pure read ref. I need to import ref as well. Ref base. 84. I forgot a paren here. '81 eval. Yes to that one, no, no, yes, yes, yes. Monad state. Has ref state. Oh, it's ref env in the current vocabulary. Key state comes from ref key. Not deduce monad key, because I didn't give it to you. A comes from M of A. Oh, that's interesting. I'm capturing the whole continuation. But I don't want to. I want to explicitly not have this in scope down here. Why? Because otherwise this thunk is going to hold on to the entire A for garbage collection purposes forever. So I want this thing to give back a computation that does not have this A inside of it in scope. There we go. All right. We've built memo. We've got eval and memo. So share should take any so share is going to use this memo of map non-det share, which would be our main workhorse. Interesting. I'll probably be able to generalize M now that I'm getting a better sense of the properties we need out of it. We need it to be monad plus and to have references and to have all these kind of things. So we'll probably be able to get rid of this the MS being magical, and we'll just assume one story. Okay. Memo A blind to map non-det share, but map non-det is share args. Okay, that's pleasant. I should be able to build a share 1, shareable 1F, and then you just tell me how to share FDS A to FDS, something like this. I would like this thing to exist. Share args 1, but now instead of using share, I will do. It's probably wrong. 101. What do I have to fill in the hole with? I got something wrong. Oh, this is share 1. I want that to just be that. First of all, I don't like this convention, so let's change that name. I should actually reason through this rather than try and do it entirely by pattern matching in my head. But pattern matching seems to be reasonably efficient. Oh. Share args is a terrible name for this. move into a less used portion of the namespace. So we're going to first run, we're going to memo, which is okay. We'll take an M of A. What are we memoing? We're going to memo. Taking M of A. Now we've got an... oh, that's why. Ha ha ha. I did have this probably right originally. M of A bind to sharing one F sheriff. Did my mental pattern matcher misfire? It did. Sharing one. M bind to. We've got an F of A. Sharing one takes all this stuff. Which is a mess. N is a monad, and I'm going to do this thing. So sharing one for F is not of that shape. Share one F should be of this shape, though. Now we're getting somewhere. Ever looked at reactive bananas internals a little bit? Not in a way that I could actually meaningfully comment about them at this far of a remove, though. Whole bottom. I've got M, which goes from this to this. I've got a M, which is an F of A. Share one. T0 is a ambiguous type. Interesting. So I can run this, I'll get an F of A. Now, I want to call sharing one. Sharing one has this monstrosity of a type. I do know that share one F. My intuition is that share one of F, because share was this last argument. Oh, I should have like a FA here. I have to compute this stupid thing. FA is this argument. So in sharing one, what do we know? We know that N is MS. Is this just share? What do I do with F here? I guess I share one F in this situation. No. I really should just work through this thing rather than trying to seat my pants and then just move on. I don't want to, though. Haven't needed it yet. There's the hypothesis that I would even want it. Let's come back to it when we know more about it. All right. Da-da-da-da. Somewhere around here I have the actual window. With the paper. There we are. So whoever sent me this link to this paper is definitely spot on. So less pattern matching. Pattern match in every call to bind in order to thread the store through the computation. So they move from state to const t, but I'm already continuation passing. And then this is the CPS reader is state thing. Searching for all sorted permutations of a list of length 20 takes about 2 minutes rather than 5. One to insert and one to compute, and one to insert evaluate results. Only had normal forms. So this is lookup head normal form. Given a version of memo that only stores its head normal forms. Build the key. Do lookup H and F key. If it's adjust something, give it back. Otherwise, compute it. And then insert their normal form. This version is different. Notice that this version actually does consciously leak this thing into the environment and has the garbage collection problem. Whereas the earlier memo, uneval. Oh, that's different. I think this might not be a conscious difference. All they're doing is storing the maybe and then leaking the reference. Like, here what we're doing is we're building a closure here that does not reference A. All it references is the key from the surrounding context. This we consciously insert. This is an uneval. In the improved version, they let the closure that they're constructing here directly reference the A from the surrounding form, and the only thing they bother to store in the maps are the normal forms. So this is an attempt to look it up and then fail and then do the insert. Consequence, it cannot be garbage collected as long as the computation returned by share is reachable, which is the observation that I was already making. So, but they see a performance gain. So, you know what? I'll steal their wisdom and just do it. Back. Other window. Where did my Terminator session go? it VxServe got really VCXServe got really confused, as far as I can tell. Maybe I can do this on this window instead. Come on. It's off screen because of the way I switched everything around. Fine. Restore. Just come back, window. I have to hover over a thing, wait for it to show, click on it, maximize. I can get it to come back maximized. Let me save that thing, close all this stuff out. I can't get it to minimize in a form that it'll let me drop it on another window though. Oh wait, there we go. Sweet, we're back. Bring back my Twitch chat. Have I had a look at Lamping's algorithm for optimal sharing? I have. It's the kind of thing that I tend to avoid thinking about too much, but I find it like pretty weird, I admit. All right, clean up trailing white space. Sharing share. Let's go back to sharing, like the other notation. We'll stir our copy down here. Blurg. New ref storing nothing. We'll actually leak the ref. We'll compute M of A. This didn't actually really help other than the fact that, so this is the usual story that my refs have, right? Which is that now this is just A. So we get an A, we use it, otherwise we do this thing. Okay, fine. Memo can be lifted all the way out of here into ref, I think. Source sharing, or source common ref base. We'll just drop this in here. Memo is a general purpose combinator that we can have. So what do we need in order to make this thing go? We need enough in order to run memo. That's about it. So I can latch onto that and generalize this by picking up the constraints on M. What do we want? We want all this crap. Oh, I've lost it. Go back to the other window. So none of this stuff needs FD monad. It just needs this stuff. Whee! That got pretty verbose. If you can run... Oh, notice that that doesn't have the M showing up on the outside. For all SM, this thing moves out here. We want to give us the choice of monad that satisfies these constraints. Maybe. That's a hell of a bound, or a hell of a constraint, isn't it? For a little internal function. Maybe I can do this. This is for all B. So it's just N. That looks plausible. n. This is all part of the help. Oh, you're small enough. Almost. I'll just change my font size. Make everybody else have trouble reading. No, it's too big. Even I can't deal with that on this stream. Default sharing, all that stuff. Blow up this font size again. Da-da-da-da. The thrashing is annoying. Yeah, I'll just keep it consistent-ish. So that gets us the help-like thing. Now, I only ever use this help n thing in the context of doing this with something after it, help n to f. Go all the way. Shared NA. Shared NFA. I don't like building big type synonyms, but if I'm going to repeat this much in a cut and paste fashion, I'm getting a type synonym, damn it. This is all under the lambda. Ugh. For all of this, given these constraints, I will give you this to this, and then I will give you back that to that. Ugh. Sharing NA, sharing FA, sharing NFA. This is going to be a sharing NFA, sharing NA. This thing is awful because this is a sharing NA to a sharing NFA.
Hello, streaming husband.
Hello. Sharing NA to sharing NFA. That's more tolerable. Now I don't have to repeat myself over and over again if that constraint ever changes. But now this should be able to do M. I just need to have that pile of constraints. And screw it. Monad state SM, monad or has reference environment S for key state of M, monad key M, shareable A. This is why I wanted to backpack all this crap in the first place. And then share does this thing for same exact signature. case is complaining because it doesn't have lambda case.
Making dinner. Do you want any?
I like food.
Okay.
Thanks. To do BSD clause or fetch2. Alright, that's all good. 60 default. Why are you? Why is it saying there's a tab here? I should have some expand tabs set. Why are those different? Oh, those are different monads. So that's why that needed the knowledge of the particular monad it's working in, right? Because that way I can have it pull out of context and use it here and have it be the same as the outside. That's really kind of annoying because I kind of wanted to be able to just. That was a big refactor too. Went from a good state to a bad state very quickly. This is a to n of a, but it works. So that's kind of annoying too, because I want this m to be runnable. But n doesn't have any m's in it whatsoever. So this is running sharing, but picking n. Now, why do n and m have to be different monads in the original sharing paper? Interesting, they're not. In the original paper, map non-det had one m, which is the thing I'm seeing that I need. I'm gonna lock them down. See what happens. We'll lose a bunch of genericity, but monad state SM, all this crap. give me the huge pile of constraints, and I will take a m of b to m of b in the style of the original paper, and we'll learn all the life lessons along the way, because there's only so many of them. Here's the pile of constraints. Given that thing, I'll give you that thing. But for enough here. So we come down to sharing. And we're going to get a very similar signature. For my heavily monomorphized version of this thing. Well, heavily unmonomorphized version of it. We go from that to that. Now I got to do the same thing for this thing. So now we pick up even more constraints. And the comedy ensues. Generic, blah, blah, blah. Okay, this is for all shareable. Though I did screw that up. That for all shareable B should be in here. For all B, shareable B. That thing stays. Okay, so for every monad such that we have the ability to create references in it, we can do this. So we have all these other constraints. For all B such that we have shareable B, m of B to m of B, a to m of A. Then we come down here and we repeat ourselves one more frickin' time. Sharing one says, you can do this for A. I can do it for f of A. Then I repeat myself again. But now, with the generic constraints, all that stuff, there's a few constraints. Hold on a second, I'll be out. I'm just trying to get this thing to type check before I end. $47. I would go for that. Share M. But we broke share still. M bind to sharing share. Okay. Do we have any ends left? Let's kill this share code. I just want to stick with things that actually... Monad state, monad key, shareable A. And the end goal should be that share should type check.
This should help.
Thank you. Let's go look at sharing. Make sure I didn't screw something up. For all B, such as shareable B. A to M of A. Generic A, rep A. All this stuff. That looks plausible to me. All this stuff again on the monad. The new constraints. Okay, I just screwed it up by trying to... This is an unrelated bug, because when I had tried to say they said the same signature, I was wrong. And now we don't need to monomorphize staff demonad, and we didn't need all that backpack stuff in the first place. Maybe I should have read the paper a little further. But we made it through getting eval and share. I haven't learned anything about how to use them yet. But I think maybe that's a good place to pick up next time. Because we've worked through... Let me commit all of this stuff. I'm going to merge this back. Move... Make sure I'm looking at the right directory. Good. Move... That's the old signature that we were playing with for a very brief period. Now we're back to it being a source directory. And we thrashed a bit, but in the end, 532. All right. Optimize types, inline definitions. So this gives us a target benchmark. Searching all sorted permutations of a list of length 20. Narrowing and unification of logic variables and all that kind of stuff is the stuff that the rest of the library is for. And I expect to lose on all the benchmarks because everything is written in this painfully generic style right now. As a learn my way around the problem space. Capture, be accurate, and then we'll be fast. All right. Oh, wait, I have that list thing that we started the stream with. Make sure I don't need it. There we go. So maybe next time or in a subsequent stream, or if somebody wants to send me some benchmarks and see how horrible I did performance relative to the Sebastian Fischer code, I would love to see it. I think this is a good breakpoint. We've accomplished a discrete goal, and I will see you folks next time.